sklearn, Model Selection, Grid Search CV. Description: Grid Search CV is an exhaustive search over a specified parameter space for an estimator. It aims to find the best hyperparameter combination for the estimator by systematically evaluating all possible combinations of parameters within the defined grid. Inputs: estimator and estimator instance. This is the machine learning model you want to tune. For example, a logistic regression object from scikit-learn. Paramgrid, a dictionary or list of dictionaries. This defines the parameter space to search. Each key corresponds to a parameter name of the estimator, and its value is a list of possible parameter values. Scoring a string, e.g. accuracy, precision, recall, or a callable, e.g. a custom scoring function that defines how the performance of the model will be evaluated. CV: an integer cross-validation generator, or an iterable that defines the cross-validation splitting strategy. It determines how the data is divided into training and validation sets for each iteration of a grid search. N jobs: the number of jobs to run in parallel. If set to -1, it uses all available processes. Outputs: best estimator, the best estimator found during the grid search, with the optimal hyperparameters. Best params: the dictionary of the best hyperparameters found during the grid search. Best score: the best score obtained during the grid search, based on the defined scoring metric. CV results: a dictionary with results of each parameter combination, e.g. mean test score, standard deviation, parameter values. Steps: parameter grid definition: you define a dictionary paramgrid specifying the parameter space to explore cross-validation for each parameter combination in the grid. Grid search CV performs cross-validation on the training data. This means the data is split into multiple folds, and the model is trained and evaluated on different combinations of these folds. Performance evaluation for each parameter combination. The performance of the model is evaluated based on the scoring metric specified. Best parameter selection: grid search CV selects the parameter combination that achieves the best score based on the chosen scoring metric. Metrics: accuracy, the proportion of correctly classified instances. Precision, the proportion of correctly predicted positive instances out of all instances predicted as positive. Recall, the proportion of correctly predicted positive instances out of all actual positive instances. F1 score, the harmonic mean of precision and recall. ROC AUC, area under the receiver operating characteristic ROC curve, which measures the overall performance of a binary classifier. Visualization plots. Heat map visualizes the performance of different parameter combinations as a heat map. Line plots visualizes the performance of different parameter values for a single parameter, keeping other parameters fixed. Fine-tune parameters. Regularization strength controls the complexity of the model to prevent overfitting. Number of trees for random forests affects the model's complexity and predictive power. Learning rate for gradient boosting determines the step size taken during model training. Uncertainty methods. Confidence intervals provide a range of plausible values for the performance of the model. Bootstrap aggregating bagging trains multiple models on different subsets of the data and averages their predictions to reduce variance. Challenges and fixes. Overfitting to the validation set. Sample use case: if the validation set is too small or the data is not representative of the true distribution, the model might overfit to the validation set. Fixes. Increase the size of the validation set. Use a more robust cross-validation scheme, e.g. k-fold cross-validation. Use early stopping to prevent overfitting during training. Computational cost. Sample use case: the search space can be very large, leading to long training times. Fixes: reduce the size of the parameter grid by eliminating less promising values. Use a more efficient search algorithm, e.g., randomized search. Utilize parallel processing to speed up the grid search. Uninformative scoring metric. Sample use case: if the chosen scoring metric doesn't accurately reflect the desired performance, the grid search might not find the best model. Fixes: carefully select a scoring metric that aligns with the specific goals of the problem. Consider using multiple scoring metrics to evaluate the model comprehensively.